Alright, so today we're going to take a look at Unit 10, Day 7, Graphing Rational Functions. Okay, now this is a little bit different than all of the other functions we've graphed in this chapter. So that would be absolute value with a nice V-shaped graph. Then we had parabolas, the 1a, 3a, 5a, nice U-shaped graph. And then we had square roots, the little R-shaped graph. Okay, rational function is a completely different type of function. Okay, so a rational function is when you have an equation with variables in the denominator of a fraction. Okay, in the numerator, it can have some variables. It doesn't have to. Okay, but every rational function has to have some variables in the denominator. All right, and so doing that causes some problems. Okay, because as you'll recall, right, a fraction cannot be divided by 0, right? And so basically, our goal is to figure out, okay, what is going to make my denominator 0? And then secondly, how can I avoid it? Because, dividing by 0, end of the world. That's a proven fact, by the way. Okay? And so that's our main thing for today, all right? We're going to take a look at some denominators and see, okay, what's going to make them 0? And more importantly, how we can avoid those things. And also what happens when the denominator is 0. Like I said, end of the world. Okay? Alright, so let's take a look at an example. Alright, example 1. 1 over the quantity x minus 3 times x plus 5. So again, you'll notice I have x's in my denominator. Okay, so again, this is not an absolute value. This is not going to be a V shape. This is not a quadratic. It's not going to be a U shape. This is not a square root. It's not going to be an R shape. All right, this is going to be different than all of those. We can't use any of the patterns. All right, what we're going to do is we're going to focus on this denominator here. X minus 3 times x plus 5. X minus 3 times x plus 5. Okay? And like we were saying earlier, right, we don't want our denominator to equal 0, right? Because 1 divided by 0, bad stuff is going to happen. Okay? So what we're going to do is we're going to set this equal to 0, and now we're going to solve for the x values that would make this equal to 0. Now, I'm hoping we remember this, all right? Basically, what you have here is you have two factors, x minus 3 and then x plus 5, right? And these are being multiplied together, okay? So we're going to take each of these and set them equal to 0 separately, and we solve for x, right? So this is simple, right? We add the 3 over, and we get x equals 3. Subtract the 5 over, and we get x equals negative 5. Okay, so these are my x values that make us divide by 0. Okay, and so on the top right, when it asks for the domain, we're going to say that x cannot equal those two numbers. Okay, because if x is 3, right, as we clearly showed down here, right, if we plug a 3 in, this whole thing becomes 0, and then my denominator is 0, and again, end of the world happens. Okay, so x cannot be 3, x cannot be negative 5. All right, and now the next thing we're going to talk about is this weird word down here below the domain. Vertical asymptote. 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 Yeah, it takes a little bit of getting used to. Okay? Basically what happens is, at the x values that make our denominator 0, we get what I like to affectionately call the Berlin Wall. Okay? And here's what I mean by that. On our graph, at x equals 3, I'm going to draw a vertical line and my graph cannot cross that vertical line. Okay, and same thing at x equals -5. Okay, so whatever x values make us divide by 0, which again in this case would be 3 and -5, those create these vertical asymptotes, or these, Berlin walls, these barriers, okay, that our graph cannot cross. And those happen at x equals 3 and x equals -5. Okay, so these are the equations of my vertical lines. All right, these vertical lines are always going to happen whatever x values make the denominator equal to 0. Okay, now, so all we've determined so far is basically what we can't have. Okay, it's a very negative view. All right, and so let's talk about points that would be on our graph. Okay, and now there's no real pattern for rational functions. Okay, you have to just plug in x values. There's no 1a, 3a, 5a, a over 1, a over 3, a over 5. There's none of that. Okay, and so on my table, I'm going to insert -5, and I'm going to insert 3. Okay, and now I'm leaving a little bit of a gap, okay, because this is supposed to be like on my graph, right? Drawing in those vertical lines gives me, like 3 sections. I have an area to the left of -5. I have an area in between -5 and +3. Then I have an area after 3. Okay, and my table is also in 3 little pieces now. Okay, now here's what I know. When I plug in -5 into our function, we are dividing by 0. So there's no y value, right? That's where I have this vertical asymptote, this barrier that I cannot cross. Okay? Same thing when x equals 3, right? That makes my denominator 0, and so I cannot cross. Okay? Now, let's talk about some values that we do have. Okay, so I'm going to pick an x value that is smaller than -5. Let's do -6. Okay, now I'm going to pick some x values between -5 and 3. So let's go with, I don't know, we can plug in -1, see what happens. Okay, actually, sorry, I'm going to change that out. Let's go with the -4. Okay, and then I always like to pick 0. 0, if you can pick 0, it's a good number, because 0 is easy to plug in. Okay, it really doesn't matter, though, what x values you're picking, as long as you're picking numbers that are in the middle of your two asymptotes. Okay, and then after 3, we can pick a couple values. How about +4 and 5? Okay, and so now what we're going to do is we're just going to plug in some of these values into our function. All right, so if you have a calculator, this is a really good time to bust that out. If you want to do this by hand, feel free. It's probably going to be a little bit tougher. Okay, and you're also going to notice that most of these values are really small. Okay, all right, so let's give this a shot. So first one, let's take -6, and we're going to plug it in for x. Okay, so this is going to be, I'm going to zoom in here, sorry. Let's do f of -6. So that's going to be 1 divided by -6 minus 3 times -6 plus 5. So if you have a calculator, feel free to go ahead and plug this in. All right, if you don't, we're going to do this by hand. So we get 1 over negative 6 minus 3 is negative 9, and then negative 6 plus 5 is a negative 1, and so we get 1 over negative 9 times negative 1, which is 1 over 9. And 1 over 9 is about 0.11 as a decimal. It's actually 1 repeating, but we don't have that much space. Okay? And so let's go ahead and write in about 0.11. Okay? And so we're going to do the same thing for all of these x values. Okay? So our next one is going to be negative 4. So let's take negative 4 and same thing. I'm going to zoom back in. And let's plug that in. F of negative 4 is going to be 1 over negative 4 minus 3 times negative 4 plus 5. And let's see, that's going to give us 1 over negative 4 minus 3 is negative 7. Negative 4 plus 5 is going to be positive 1. And so this is going to equal 1 over negative 7. So negative 1/7, which, again, we're going to approximate with the decimal here, is about negative 0.14. Okay, so in my table, I'm going to go ahead and write in negative 0.14. That's a bad 4. Let's try that again. That one's better. Okay, now we would do the same thing 3 more times, but for time's sake, let's just go ahead and fill in the rest of the table together. All right. So when I plug in 0, I should get negative point. This is going to be about 0.7. And let me rewrite that. 0.07. So again, very, very tiny values. Okay. Plug in x equals 4, we should get 0.11. That one's actually also 1/9, just like negative 6. And when we plug in 5, we should get 0.05. Okay. Now, this may not look like much, okay, but we don't really actually care about the y coordinates here. All right. Here's what we do care about. Okay. We care about if they're positive or negative, and I'll tell you why in a minute. So first, let's just graph the points we have here. We have negative 6 and 0.11. And so that's going to be negative 6 and 0.11. It's going to be just above my x-axis. So very tiny point. Okay. And then we had what? We had negative 4 and negative 0.14. So that's going to be just below my x-axis. Then we had, let's see, 0 and negative 0.07. So that's actually going to be right there. Okay. So again, just below my x-axis. Okay. And then we have 4 and 0.11. So that's going to be just above. And then we have 5 and 0.05. So that's going to be, again, just above the x-axis. Okay. So like I said, very tiny y values. Okay. And there's a reason for that. Okay. And that's because all of these graphs, while there is no pattern like 1A, 3A, 5A, they're all going to basically have the same shape. Okay. So starting back on the left, knowing that when we plugged in -6 we got a positive number was very helpful, because that tells us that our graph is going to look something like this. Okay, where it's going to follow along the x-axis, all right, and then as it's about to hit, remember, our vertical asymptote, this is like our Berlin Wall here, we cannot cross this, okay, it's going to then curve up and follow along our asymptote. Okay, now, when we plugged in -6 and we got a positive number, that tells us that our graph has this type of shape. Okay, had we plugged in -6 and gotten a negative number, right, that would have told us that our graph would have been going down and doing the same thing. It would have been hugging along the x-axis and then going down and following our asymptote. All right, so that's what I was saying earlier. We don't really care about what, the 0.11 doesn't really matter, right? Because, it's really hard to graph 0.11 anyways. But we do know that it's positive. And again, that's going to tell us the shape of the curve, which is super important. Okay? Now, we can do the same thing in the middle of our graph. Between my two asymptotes, I have 2 points that are below my x-axis. And so I'm going to have kind of like the same thing, but I'm going to follow my asymptote, and then it's going to kind of look like a parabola here in the middle. Okay, so I intersected my 2 points at -4 and at 0, all right, and so I follow the asymptote, right, and then I stay under my x-axis, and then I come back down and follow the asymptote again. So this one's not like a perfect U shape, but it's going to work every time. Okay, and now we do the same thing to the right of the vertical asymptote at x equals 3. Okay, when we plugged in 4 and 5, we got positive numbers, and so that means my graph is going to do something like this, where we're going to follow the asymptote and then stay above the axis, hitting the points that we plotted earlier. Okay. And so a lot of the graphs are going to look like this. Okay, they're going to basically have this same shape, right? But on the right, this piece here could have been going down, right? It could have been like that. The middle piece here could have been going up like a regular parabola. Okay, and this left piece could have been going down like this. All right, so that's really the only thing that changes whenever you have two asymptotes. Okay, now technically the middle doesn't have to be a parabola, but we're not going to see anything that's that crazy. Okay, so this is going to take a little bit of practice. This is easily the most different thing we've done this chapter. Okay, all right, so let's take a look at another one. Okay, so on example 2, first thing that you'll notice is in the denominator, right, x squared minus 5x minus 6, that's not factored, right? So we're going to have to factor x squared minus 5x minus 6. Now hopefully you guys remember, right, to factor we're going to use the little x, okay, -6 goes on top, -5 goes on bottom, and so that's going to be, I think, -6 and +1. And so that means I can rewrite my denominator as x minus 6 times x plus 1, and that is going to equal 0. Okay, and so I go ahead and factored, right? And now I set my factors equal to 0. So x minus 6 equals 0, x plus 1 equals 0, and so I get x equals +6 and x equals -1. Okay, now for my domain, I say that those are the two numbers x cannot be. Okay, because if x is those two numbers, well, then we're dividing by 0. That's bad stuff. okay? But for our vertical asymptote, I'm going to say that those are the equations of my two vertical asymptotes, right? So vertical asymptote is going to be a vertical line. So we're going to have a vertical line at x equals 6. We're going to have a vertical line at x equals -1, okay? And so let's go ahead and graph that. All right, so vertical line here at x equals 6. This is one of my two Berlin walls. And let's put the other one at -1. Okay, so there's my two lines that I absolutely cannot cross when graphing this. Okay, and so I'm going to go ahead and put those two numbers on my table. So I will put -1 right there, and I'll put 6 right there. Okay. So now let's pick some other x values around -1 and 6. So something smaller than -1, how about -2? Something between -1 and 6, how about 0? How about 2? And how about 4? Those are all between -1 and 6, right? You know, you could have picked 1, 3, and 5. You could have picked 2.7, 3.8, and 4.936. You can pick whatever you want, okay? But pick something easy for you, all right? And then after 6, how about 7? Okay. And so now we do the same thing we did last time, right? I'm going to have to take these x values and plug them into my function. Now, here's what I know. Okay, I know already -1 and 6, when I plug them in, I'm not going to have y values because those were where I had vertical asymptotes. So I only have to plug in the other 5. All right, so again, we'll do 2 of them, and then I'll give you the rest of them because we're running low on time. Okay, all right, so let's start with -2. So this time, actually, is this function called f? Yes, it is. Okay, so f of -2 is going to be 2 divided by -2 squared minus 5 times -2 minus 6. Okay, and so this is going to be 2 divided by, let's see, -2 squared is +4. -5 times, whoops, that should be more of a negative there. -5 times -2 is +10. And then minus 6. Okay. And let's see, this is going to be 2 divided by 4 plus 10 is 14. Minus 6 gives us the ocho. Okay, and 2 over 8, hopefully you recognize, is 1/4. And so this one, actually, no rounding needed. This is just 0.25. Okay, so let's go ahead and plug that into our table. So we get 0.25. Okay, and let's do one more of these. All right, let's do f of 0. Let's plug 0 in, and let's see what's going to happen. Okay, so f of 0 is going to be 2 divided by 0 squared minus 5 times 0 minus 6. And so this is going to equal, whoops, this is going to equal 2 divided by, let's see, 0 squared is 0, minus 5 times 0 is 0, and so I am just left with minus 6, and so 2 over -6 is -1/3, which is about -0.3 repeating. So we'll say -0.33, a little Scottie Pippen number there. Okay, so let's go ahead and write that one into our table as well. And also, this is why I really like plugging in 0, because if you plug in 0, right, your x's will always cancel out, which is very nice. So we get -0.33. All right, So like I said, I'll do 2 of these with you, okay, on the quiz or the test, right? Actually, the test. You would have to plug in all 5. So calculator is definitely your friend here, okay? All right, and so now let's go through the rest of these. Okay, I will just give these to you for time constraints. Okay, so plugging in 2 into our function is going to give us negative 1/6, which is about negative 0.17. Plugging in 4 is going to give us negative 1/5, which is negative 0.2. Okay, and then plugging in 7 is going to give us 1/4 again, which is going to be 0.25. All right. So again, it doesn't really matter, right, what these numbers are because they're really hard to graph anyways. What we really care about is the positives and negatives, okay? And as it turns out, this graph is actually going to have basically the exact same shape as the last graph that we did, okay? And we'll see why. We'll do this piece by piece. So starting to the left of the asymptote at -1, I have the point -2 and 0.25. So that is going to be this point right here. Okay, and now that tells me that my graph is going to be something like this. And actually, I'm going to zoom back in. My graph is going to look something like this. Okay, it's going to hug the asymptote coming down, and then it's going to hug across the x-axis. Okay, let's do the same thing for my points in the middle. So we had 0 and negative 0.33, so 0 and negative 1/3. We had 2 and negative 0.17, so a little bit higher. And then we had 4 and negative 0.2, so it's really hard to tell. Okay, so I'm not expecting amazing graphs for these. Okay, it's really more the shape of the curve that matters. And again, we're going to get like this upside down parabola here. And ooh, that's really bad. Let me start that over. So it's going to look something like this. Okay, because when we plug in 0, 2, and 4, we get these negative numbers. All right, and so that tells me my graph is going to be below the x-axis. Okay, and last one. All right, when we plugged in 7, we get 0.25, just like when we plugged in -2. Okay, and so that's going to tell me shape of my curve is going to be something like this. Okay, and so again, right, it just so happens that this graph looks a lot like the previous graph. Okay, so a couple of keys just to wrap things up here. All right, the first thing you want to do is you want to identify where your vertical asymptotes are, aka what your domain cannot be. Okay, take your denominator, right? Set it equal to 0. Now you might have to factor. Okay, hopefully you remember factoring, right? It wasn't too long ago. Set your factors equal to 0. Domain cannot be those numbers, but that is where you will draw in the vertical lines that you aren't going to cross. Okay, and so that's going to split your graph up into 3 kind of regions. Okay, pick some x values from each of those regions. Pick one to the left, pick a couple in the middle, pick one to the right. And then what you're really looking for is what are the signs here, right? These 3 were all negative in the middle, and so that tells me I get this U shape going down. Okay, to the left and right I had positive numbers, and so that keeps my kind of L shapes here up above the x-axis. Okay, all right, so that is all we got. Okay, whoops. I will see you guys next time.